All right, fall final review. We're looking at 31 through 40. We're on page 6. Right now, we're writing the equation of a line based on whatever information they give us. So for 31, they give us a y-intercept of -12 and a rate of change of -6. With that, y-intercept is also a point, so that would be 0, -12. And it's also the b value in my equation for slope-intercept form. Rate of change is just another word for slope. So this one's got a slope of -6, which is m. So that means I've got slope and I've got y-intercept, which means I'm going to write this equation in slope-intercept form, which is y equals mx plus b. So I've got y equals my slope of -6, x, and then my y-intercept of -12 to get my equation. Same thing with 32. We've got a slope of 2, a y-intercept of -4 or -3. So that means that I've got m equal to 2, b equal to -3, which means I can write a nice equation of y equals 2x minus 3. 33, we're still looking at finding the equation, except this time they're giving us some different information. So they want it parallel to that equation and going through the point -6, -3. If we're looking for something parallel, alarm bells should be ringing in your head and you should be thinking same slope. So right now, my slope is 5/3. So if I want to keep the same slope, I still want a slope of 5/3. But I want it to go through the point -6, -3. So that's an x1, y1 for the information. So if they're giving me slope and a point, then I'm going to use point-slope form to write my equation. So point-slope form is that y minus y1 equals slope times x minus x1. So I'm going to plug each piece in. I'm going to get that -y1, my slope, and my x1 plugged in. So I have y minus -3, so it's the opposite, and is +3, equals my slope of 5/3 times x minus -6, which is going to be opposite and be x plus 6. With perpendicular, really similar, except we're looking towards that opposite piece. So this time I want it perpendicular, so I'm focusing on the slope there, and I want it to go through the point 12, -5. So I've got to think that I want to do the flop slope. That, right now, my slope is 6, but I got to do something. So the flop is to flip the fraction, so it goes from being 6/1, so where my perpendicular slope goes from 6/1 to 1/6, and then the opposite to go from positive to negative. So then my slope for perpendicular becomes -1/6. I'm going to use that slope and my point over here, which I'm going to label x1, y1, to write another point-slope form equation. So I've got y minus my y value, so y minus -5, which is going to flip it to the opposite and be y plus 5, equals my slope of -1/6, parentheses, and then I want x minus my x value, so x minus 12, there. Okay, next one. This time I want it parallel to the x-axis and going through the point 2, 3. So with this, you've got to kind of think about what the x-axis is. So when we're looking at the x-axis, it's my horizontal axis. So my x-axis is already hoi. But I've got to also look over here. Parallel means I want it the same. So I'm going to keep hoi. With hoi, that's a horizontal line with a 0 slope and a y equals equation. So I already know my equation's only y equals, which means I could go eliminate some answer choices if I was looking at my final. And then I want to look at, do I want 2 or 3? Difference between, do I want x or do I want y? Well, with hoi, I want y, so I'm going to focus on my y value of 3, and my equation is going to be y equals 3. On 36, this time we want it perpendicular to the x-axis and going through the point 57. So really similar steps to the last equation, but we're going to go just a little bit further. So this time I still want to think about, if I'm looking at my x-axis, it's my horizontal one. So I'm still saying, okay, x-axis means that it's hoi. But this time we want perpendicular, so it's going to be the flop, which means it's going to take and do the opposite of hoi. So I don't want it to be hoi. I want it to flip and be vux, because it's going to cross my x-axis instead. So we're looking for it to be vux, which means when I look at my 2, I want the x value, because vux means I want the x value, x equals equation. So my equation becomes x equals 5. 37, y varies directly with x. Y is 72, x is 30. Find the equation that represents the situation. Okay, the y varies directly with x should automatically tell you that this is proportional and it goes through 0, 0. So I've got 0, 0 already in my table. Then I've also got an x and a y value that are going together. So then so y is 72, so it goes in the y part. And then x is 30, so I have the point 30, 72. So I'm going to take that, put that in stat to find that equation. So when I put that in my calculator and I find stat, then I end up getting, so I already know that I should have nothing on the end, and I end up with that equation of y equals 12/5 x when I go through stat. All right. 38 is a system of inequality. So we're looking at pulling these through together. So 2 different ways to kind of go about this. We can do it with making sure that it's in slope-intercept form or with intercepts. So I'm going to do one way, one the other way, so you can see both. So I'm going to make myself some room when I'm solving. I'm going to pull this over, say this is x plus y is greater than 3. I want it slope-intercept form, so I want y to be isolated. So that means I got to deal with that x and subtract x on both sides. So then I get y is greater than negative 1x plus 3. That gives me my slope and my y-intercept, but I got to talk about that sign. So I'm going to test a point when I go to make that happen to make sure I know which way to shade. So with that, if I want to test like the point 0, 0. So if I test that point 0, 0, then y becomes 0. That x is completely canceled out. So we're looking at, are we looking at 0 greater than 3? Is 0 greater than 3? Nope, it's not greater than 3. So 0, 0 is not going to be a solution. So let's see what happens when I go to get this through it. So I'm going to graph my y-intercept at 0, 3. And I want my slope to be negative 1. So it'll be down 1, right 1, down 1, right 1, down 1, right 1, over and over. It is a not equal. So since it's not equal, we're going to have a dashed line. So I'm going to dash that line all the way down to show that it's not equal. Okay, and then 0, 0 right there is not a part of my solution set because we already said that was a false answer. So then I'm going to shade up above. I'm going to shade where 0, 0 is not a part of my solution. Okay. The second one we're going to do with intercept method. So intercept method means I'm going to only focus on one and zero out the other. So if I'm looking for an x-intercept, I'm going to not pay attention to y, and we're going to zero y out, and I'm only going to focus on the x part of it. So that means I would have the little equation of negative 4x less than or equal to 4. I would divide both sides by negative 4 to get x by itself. But since I'm dividing by a negative, I am going to take and flip that sign. So it'll be x is greater than or equal to negative 1. So that means I'm going to have the point negative 1, 0 to plot on my graph. And then I want to do the same thing where I only focus on the y part of it. So I would I'd zero out x, so I'm not paying attention to it, and I'm only using the y part. Well, that makes it real simple. It's just y is less than or equal to 4. So that means I have a y-intercept at 0, 4. So the other thing is we can look at just those axes and figure out which direction to go. So let's put those two on there. I've got an x-intercept at negative 1, 0, y-intercept at 0, 4. I've got to be greater than my negative 1. So that means if I'm looking at the x-axis, I'm going to be shading off that away. I've got to be less than the negative 4, so I'm going to shade off that way. So it's going to tell me which way to go. Now, this one is equal or not equal. That sign is less than or equal to, so it is going to be equal, which means we're going to have a solid line. So I'm going to solid line that connects these points all the way through. And then it shades towards both. Okay, the other way to test where that shading is use that original equation. Check the point 0, 0 again, which means I would have negative 4 times 0 plus 0 is less than or equal to 4. So that means, is 0 less than or equal to 4? Yes. So that means yes, 0, 0 is a part of it. And look, 0, 0 is in there. Now, for here, if they want a point in the solution set, I want where both of them are overlapping. So that means I want this piece here that I'm currently coloring green to be my solution set. So where they both overlap, that's my solution set. So let's make a little arrow. Point, solution, set. So I want any point that's inside that solution set. So it doesn't matter which one you choose, it's got to be somewhere in the green section. I'm going to choose all the way up here and choose 10, 10, because why not? So if I had answer choices though, you would want to graph those on the graph to see which one end up inside that overlapped area in your solution set. All right, we've got 39 as a standard form equation, and I'm going to go ahead and get that into slope-intercept form to make it easy for me to graph. So I'm going to focus on getting y by itself to get it into slope-intercept form, which means that 6x is a problem, so opposite of positive 6x is negative 6x, so we're going to subtract 6x to move it to the other side. we'll get 2y is less than negative 6x minus 14. And then I still want to focus on getting just y by itself. So we'll divide everything by 2. Since it's dividing by a positive, I don't have to flip the sign. And I get y is less than negative 6x divided by 2 is negative 3x. Negative 14 divided by 2 gives me negative 7. So that means I've got a slope of negative 3 over 1 and a y-intercept of 0, negative 7. So then I want to take and use that to graph. But I also want to talk about my sign. So my sign I first got to talk about, is it equal to or not equal to? It's not equal. So when I graph my line, I want a dashed line. So let's do that part. So I got 0, negative 7, and then I want negative 3. I want negative 3, so I'm going to go down 3, right 1 to get that point on there, which I can't go any further, so I'm going to back it up and get the rest of them, and making a dashed line as I go. So dashed line to get the rest of this point. All right, and then we're going to look at how to do this shading on there. We can look at the fact that it's going to be less than my y-intercept, but I prefer to look at 0, 0. So with 0, 0, I'm going to test that point. I'm going to plug everything in. 6 times 0 plus 2 times 0 is that less than negative 14. Well, that zeroes everything out. Is 0 less than negative 14? No. So that means 0, 0 is not a part of the solution. So if I look at 0, 0, it's not going to be part of the shaded area. So I'm going to shade on the opposite side, far, far away from it, and less than my y-intercept. Okay, so with 40, it's using the question from 39, and it wants to know which of the following are solutions to this inequality. So there's two ways of going about this. There's graphing it and seeing which ones end up in the shaded region, or there's point testing. So we'll point test one of them, and then we'll graph the rest. So I'm going to use the original equation that they gave me, and I'm going to go out point testing that. So when I do that, I want to kind of leave spaces and empty shells where the x's and y's are. So 6 times something plus 2 times something is that less than negative 14. So we're asking ourselves if that's going to work. So then I'm going to use the x and the y value that they gave me. So I'd have 6 times 1 and 2 times 10 in there. So 6 times 1 is 6 plus 2 times 10 is 20. So this would be, is 26 less than negative 14? No. So that means 110 is not a solution. And if I graphed 110 onto this, it would be all the way up there. So that's my A. And that's not going to work. So I'm going to keep going with graphing these, and we'll see which ones end up in a spot that we like. So we've got B at negative 4, 2. Ooh, I like that point. But we're going to go through all of them. And C is negative 2, 1, which is definitely not a part of my solution set because it's not even in my shaded region. And then D is negative 1, 4. Ooh, so that ends up right on my line. So D is one of those ones that we've got to be really careful with my inequality. D is looking at, since it's on my line, I have to know, is it equal or is it not equal when I look at my inequality? So if we look at my inequality, since it's just less than, the line is not equal, so that means that D is not a solution. So the only one that truly works is B. All right, that's 31 through 40. Hope to see you all for the next video. Bye.